Live from the North Carolina Museum of Natural Sciences in beautiful downtown Raleigh, it's the Science Cafe with your host, Chris Smith.
Let's get started. Hi, everybody. Welcome one and all to the Science Cafe here at the North Carolina Museum of Natural Sciences. Welcome to the Nature Research Center, to our Daily Planet Cafe, where every Thursday night, believe it or not, we bring you cool and interesting stuff happening in the world of science onto our stage and give you the chance to maybe learn something new, hear about something cool and exciting that's going on in the world of science, technology, engineering, mathematics, maybe sometimes even the world of science and art, and give you the opportunity to also ask questions, right? The Science Cafe is about taking scientists out of their labs, getting them out of the lecture halls, and putting them in places where maybe they can have a beer with us, or not. There's young ones here too. And we get to enjoy a little bit of the science, learn something, ask questions, and engage with topics around science that we think are interesting. And I think for the year 2017, quite possibly the most interesting thing that's going to happen in the whole world of science is the total solar eclipse. Show of hands if you are headed into the path of totality. Yeah, that's incredible. That's amazing. That's incredible, right? That just to make it clear, like, we're spending money to go see this thing happen, right? Like, this has real tangible value to us. So I am too. Fortunately, my day off is a Monday, so I don't even have to take off work to go see it. I'm headed to Nashville, Tennessee, my hometown. Who's headed further than Nashville? It's about an 8-hour drive. Yes, I have almost all of you beat. I am more sciencey than all of you, except for like 3 of you. Cool. Oh, tell me, where are you headed? To Charleston? Well, that's only a 6-hour drive. Nashville's an 8-hour drive. It'll be 12 hours, yeah. I think so. And y'all are headed to Kentucky, to the Kentucky Lake area, yeah. Yeah, that's further than Nashville, I'll give you that. To Murphy, yeah. Cool, so there's something about this event that has captivated just about everybody. I don't know, maybe it's just I'm, in the sciences. I don't know anybody who doesn't know about this event coming up. And most people know more about it than I do, and I work at a science museum. One of those people, though, who knows a lot more about it is, she cringed when I said that, is the museum's head of our astronomy and astrophysics research laboratory, which, if you're here at the museum during regular, sort of open hours, 9 to 5 Monday to Saturday, 12 to 5 on Sunday, you can go up to the 3rd floor of this building and actually peek inside the astronomy and astrophysics lab, and you might see astrophysicists working away on their computer code, looking at images on the screens, working with some really cool software that the museum has helped develop too to visualize what's going on in our solar system and our known universe. There's always cool stuff going on that you can look in and learn about if you go check out their lab on the 3rd floor of this building. And you might get to see Dr. Rachel Smith. She's the head of that lab here at the museum, and she's also positioned at Appalachian State University. I think that I have said enough because you are all here to hear about the total solar eclipse. After her talk, we'll get into Q&A, just so that everybody knows. The way Q&A will work is that I'll have a microphone, and then I'll have some helpers out on the floor who will have mics as well. When you have questions, raise your hands once we get to Q&A. We'll bring a microphone to you. That way everyone in here and in the theater where there's overflow can hear the questions. And so look for myself or some of the other people spotted around later to get your questions out there, and we'll get to as many questions as we can. Put your hands together and welcome to the stage, astrophysicist Dr. Rachel Smith.
Thank you. Wow. Okay, so welcome. Thanks for coming, and I just want to first say, if this is any indication, there's going to be traffic on August 21st. And there'll probably be traffic before that, on the day before, which is what I'll be doing, driving. So this is awesome enthusiasm. I hope that you enjoy this little presentation I put together. And you probably all know a lot more about the eclipse already than typical people, or I don't want to say you're not typical, but you're enthusiastic about it, and that's awesome. So I'll do a little science discussion and tell you some things that I thought were interesting about eclipses, about solar eclipses, and some stuff about eclipses in history, and then I'll be happy to take your questions. So basically what happens, as you probably know, is the new moon passes exactly in front of the sun, and this happens about every 18 months somewhere on Earth. And so these are actually not rare events, but they are rare for wherever you are. And that's what's interesting. There are people who chase these all over the world, and they do this because apparently, and I've actually never witnessed a total solar eclipse, and I'm excited for this one. But a lot of really cool things happen, and I hope to show you a little bit from what I've gathered as far as information. And so essentially, is just just generally, the moon comes across, covers the sun, and it'll occur for about, the totality is about 2 minutes or so, depending on where you are, and it's supposed to be pretty spectacular. So this little animation shows how the new moon passes in front, and it takes about an hour for the shadow to cross the Earth. And for some reason, this video never wants to run, so we could just skip it. But basically, that's the geometry of the solar system and our placement in the solar system relative to the moon. The moon is about 400 times smaller than the sun, but it's about 400 times farther away. And so the geometry of how big the moon is compared to how far away it is enables it to cover the sun completely for us. And that's what's really cool. And they are the most spectacular visually to see compared to lunar eclipses, which are actually more common, and we'll see why. So what's interesting is that less than 0.5% of Earth's surface can see any single total solar eclipse. So that includes any of them that happen. And of course, what covers most of the Earth is what? Ocean. And there are cruises. You may have found some of them when you were researching what to do. I think staying in the state of North Carolina is a fine idea, or going to South Carolina, which I know a lot of people are doing, or Tennessee, but we could stay on land for this one. But certainly there are going to be a lot of ocean expeditions out every year for total solar eclipses. But there are cool things you can see on land, actually, if you get to be, if you're not on a boat, comparatively, in terms of what happens around you, and we'll talk a little bit about that. So less than 0.5% see the total solar eclipse. And this is, for the United States, this is about a 70-mile wide band across the U.S. And it starts in Oregon, ends in South Carolina, and then goes off into the ocean. And I have a timetable to show you. And if you have any questions about when it starts or how long or where you'll be, I actually have really good online tools that I found that I think would be useful, and you can type in any place you want to be and how long you'll see totality. But that's the eclipse you see there on that gray band across the U.S., and I can point to it. I don't think the pointer really makes much of a difference, but in any case, what you see is the umbra, that gray oval is the shadow of the moon on the surface of the Earth. And so if you're in that gray band, right there, if you found a place in totality in that gray band, you will see a total solar eclipse. But if you aren't going to go to the path of totality, you will see a partial eclipse. And we'll talk about that as well. So if you're interested in numbers, and we can see there are a lot of numbers out here in terms of people. This is a website that I found that just showed kind of where they think, in predicting traffic in the United States. There's about, you could see, let's see, where is this? South Carolina. Who's going to South Carolina? Well, plan ahead, folks. Yeah, Katie, awesome. I can't wait to hear about that trip. But yeah, South Carolina, which has some big cities in the path of totality, is going to be pretty well traveled. North Carolina, not so much. So if you're staying in North Carolina, as I am, you may have better luck with traffic. But honestly, these are predictions, and who knows? I wouldn't have predicted this wonderful audience. I'm so pleased to see everybody. So you can take a look. This is statistics, and actually I'm happy to share any of these websites with you. There's a lot of information online, and I hope I tried to compile some stuff that I thought was useful. Here's a timetable, so if you want to know, so if you look at these times, and it gets confusing because you have a 3-hour time difference from the east to the west coast, The eclipse will start at about 9 a.m. Pacific time, so that's noon our time, and it's going to not here though yet. It's going to be in Oregon, noon our time. So if you're eating lunch at noon, you'll think, oh, it started in Oregon somewhere, and then it goes across the United States, and those are some key cities in that table you see on the screen, and it ends in South Carolina. So roughly about the eclipse begins. This is that part when the moon starts touching the sun. This is not totality yet. So you have a lot of time to put on those eclipse glasses, and we'll talk about that. To put on your eclipse glasses, look up and see the moon starting to cover the sun. So there's actually a lot you can see before totality happens. Then totality begins, and that's when you can take your glasses off. And that's when all the really cool stuff is supposed to happen. That's at about 2:41 p.m., and roughly about 2:44 it will end. And so you have about 2 minutes or so. The longest is roughly 2.5 minutes, depending on where you are, to see totality. And that's the only time when you can take your glasses off. And then the eclipse ends, meaning the moon is totally over the surface at about 4 p.m. our time. And it depends on, I have these, all these sites enable you to type in exactly where you want to be. And it gives you the exact time. And they're interactive maps, and they're really cool, and they're useful. And so you can type in exactly where you're going to be and know the time. This eclipse2017.org is a really nice tool. I took a screenshot of it for some cities in North Carolina. The ones in bold will be in totality. I happen to be going to Silva for a program related to App State, and we have some of our AV guys here coming to stream that into the Daily Planet. So if you're planning on being in Raleigh for whatever reason, you can come here and you can see our stream from Silva. And if you're close to that blue line in North Carolina, in that center line on that gray swath there, that's where you get the most time. And so we have about 1 minute and 44 seconds in Silva. And then if you're anywhere along that band, as I said, you'll have some totality. So here's some other sites. This is an interactive US map. I spent considerable time playing around with it, more than I needed to in preparing, but it's fun. And you can see on this map, you could just go to any of these websites. You can take pictures of these screens, that's totally fine, or you can ask me later and I'm happy to share these with you. And I just zoomed in on our area, and you can see the kind of this idea of where you need to go. And roughly it's about a minimum, I think, actually I don't know exactly, but 4 hours I'd say is probably a minimum of how far you have to travel. And then keep in mind, if you believe in the predictions for statistics in terms of population, you know, who's going to travel? I mean, about 1 million people are in the path of totality, and they think that 60,000 people roughly might travel through North Carolina. And so if you're thinking about that, and then South Carolina even more in planning your travels. So here you see a zoom again in North Carolina, and the oval, which is the umbra, the shadow of the moon, over the state. And if you're in the very western part of the state, you will see in that path, that's where essentially that part of standing in that oval, when you're in there, that's where totality happens. And anywhere across that band. Anyone going to the West Coast, by the way? Oh, okay, that's interesting. Yeah, so West Coast, it turns out, I hate to be negative about the East, but the West Coast has the best weather predictions, usually around this time of year. So the most expensive flights and the most expensive hotel rooms now, and I actually spent some time last night just looking at these crazy places people are renting. People are renting like their pasture field for $2,000 so you can set up your tent. I mean, it's insane, and it was really crazy, but which gave me some ideas for future eclipses. Maybe we'll rent out a barn or something. But people are going to making a lot of effort and spending a lot of money to experience this, and you can find all these online. There's Airbnb for you. You can play around with that. This is just a zoom. So center line of North Carolina will be the closest destination for 1.2 million people roughly, and that gives you some sense of what is going to happen that day. Traveling the day before is highly recommended. Traveling the day after the eclipse is also recommended, something I'm not doing, but we'll just hope for the best there. So what if you're not going to be in the path of totality? And is anyone going to be here in Raleigh? Oh, okay, good. So this part's for you. So what if you can't get to totality? I took these images. This was from 2012 for the transit of Venus. Same thing, you need glasses. So Everyone has their Eclipse glasses, right? So you take your glasses. You can use this anytime. Does everyone have glasses? Oh, I'm sorry. Okay, we'll work on that, yeah. So you put your glasses on. You can get them. I've collected over the last year glasses from random places. And you put them on, and you can look at the sun, and you can test them out. I've done this. And actually, if I'm looking through the window, I in fact see it right now. It looks like a orange ball. It's kind of small, but you'll need these if you're not in the path of totality and you want to look at the sun. And you don't want to look at the sun and do what that person did that has a no that I put on there. Those are sunglasses. That is not good. Don't do that. Of course, he's not looking up, so we're okay, but those are not solar glasses. These are it has to say solar eclipse glasses, just FYI. And there's fun facts on the back that you can read on your glasses, depending on where you get them. All right, so, or if you have access to a telescope, there are solar telescopes. And the one I'm showing here shows the sun as an orange ball, and that's what I'm showing on the bottom image there. That happens to be Venus, but it doesn't matter, because anytime the sun is there, you need your glasses or your filter. The image on the top is a white light filter, so you can buy special filters for cameras, binoculars, telescopes, whatever, to block out the harmful rays of the sun. The solar telescope I'm showing there is only for viewing the sun, so it has built into it a special filter that only shows you hydrogen, which of course is most of the sun. And that is why it looks red. But it doesn't matter. You can see an eclipse with a white light filter or a solar filter, an H-alpha filter there. And we'll be taking that telescope with us for the eclipse in Silva. All right, so that gets through our safety discussion. So you don't want to look at the sun, and you don't want to, you'll not only hurt your eyes, but you'll also break your equipment if you try to take a picture through a telescope without a filter. So even if you're not looking at it, you'll ruin your equipment. Okay, so just some fun facts that I think are kind of interesting. Eclipses come to the same location once every 350 years. So that tells you that if you are in the path, like Silva, for instance, roughly speaking, that total eclipse won't come back to that town for another 350 years. It gives you a sense of how unusual it is to be at the location of a total solar eclipse. So the last total solar eclipse in the United States was February 26, 1979. So I thought it's fun to see what was happening back then. If that doesn't seem like so long ago, remember what was happening in 1979. We had that guy as president. That was a personal computer, and that happened to be me, looking like much like the dork I am today, but with a better haircut, you might think, I don't know. I got annoyed with my mom. I was like, what? She sent me that. I'm like, come on, really? But anyway, that's seems like forever ago. Really kind of wasn't, but things changed rapidly. Some other things that happened, Space Invaders. So you have this video game, which was all the rage back in, which we don't think of necessarily as fun. And and my all-time favorite, honestly, from 1979, was this little commercial that I'll just let play for 30 seconds.
Sony Walkman, you really feel the music with the Sony Walkman.
The Sony Walkman is a tiny stereo cassette player with truly incredible sound.
You really feel the music, you really feel it. You really feel the music.
Put on a Walkman and see the world in a whole new light.
Sony Walkman.
The Walkman from Sony, the one and only.
That could be like 1879 or something, but it's, that was a while ago. So you might make time for that, for the next, this eclipse, if you think that it comes around a lot, very often. I really liked my Sony Walkman. I'll just add that in. So the next eclipses here in the U.S. are going to be 2024. So not so bad, but not here. So you really have to travel about 350 miles or so north. But Vermont, Maine, New Hampshire, so that's not so long to wait. But then you have to wait until 2045 for the next one after that. All right. So 1979, super fun time. But there were other eclipses, total solar eclipses, that I thought were kind of notable and interesting. The one in 1780 was a botched attempt. This was kind of interesting, I thought. Samuel Williams, who was a Harvard scientist professor, not really I wouldn't call him a scientist because he kind of messed up his calculations. Well, it happens, you know. But it was interesting because it was during the American Revolutionary War, and the British gave him passage to view the eclipse on Long Island, and he messed up his calculations. So even though they got safe passage during the war, because science won out over politics, yay, unusual times. But he messed up, so that was kind of sad. But there are interesting stories about a lot of eclipses. There was other attempts with Venus, but in any event, 1780, they were interested in these solar eclipses. They tried, and that one didn't work out. But in 1868 was actually the discovery of helium, during the total solar eclipse, named after the sun, and that's pretty cool. So we think of helium, lifts our balloons, although you don't want to release those, I guess. I don't know. They're not so good, I guess, for the environment. But whatever, they're pretty, and we need helium for them to go up. And but helium is a second most abundant element in the universe, and it makes up a lot of our sun, and we need it. So that was discovered from a total solar eclipse observation. Earth's shape was determined by its shadow on the moon during an eclipse. So you do see the shadow of the Earth sometimes on the moon during a total solar eclipse. And then they believe, this is not in any records, that Lewis and Clark in 1806 would have experienced a total solar eclipse during the exploration of our young United States. And so that's possibly was part of their experience. 1869, this is actually just showing a photograph of the front page of the Montana to North Carolina eclipse, and these are images from that. They took photographs of that. And this was kind of cool. Einstein's theory of relativity, one of the tests for that is looking at something called gravitational lensing, which is where light bends due to gravity. And they were able to test this, and they actually do this, so I understand, for every total solar eclipse, is they look at the stars right around the sun that become visible when the sun is up during a total eclipse, and you can see the bending of the stars, of the starlight from the sun's gravity. And so in 1919, they tested this theory of relativity using stars in the constellation Taurus, the bull, which were near the sun at that time. And so these are actually images from that eclipse. One is the negative of the other, so they're both kind of cool to see. And so that was a test for Einstein's theory. So this is getting into some of the more advanced science that actually can be done during total solar eclipses. They're not just fun to look at, they're actually interesting for scientific reasons. Just to take note, the moon is moving away from Earth about 3 centimeters a year. We know that from mirrors that were placed on the moon by Buzz Aldrin and company during the Apollo missions. This is an extrapolation of what the moon would have looked like about 85 million years ago, slightly bigger, and future humans, I literally just thought, I just saw that online. I was like, well, they might look like that. We don't know, but they wouldn't see a total solar eclipse about 1 billion years from now, so they'd look sad like that, I imagine. All right, so if you want to ask, there's someone here who might ask me, well, when are the next eclipses? And I want to know all the timetable. Well, this is the slide for you, because this takes you through the year 2199, and I played around with it. It's great for wasting time because I did that. And it'll give you the paths of all the eclipses up until the year 2199 in 10-year increments anywhere in the world. And it doesn't just cover total eclipses. It covers annular and hybrid eclipses, and I'll talk about those in a second. But this is a fun tool, and if you want to see the path across the United States, it turns out in 2199 there will be one in North America, because of course I went to the latest thing I could find. But it's a nice tool to use if you're interested in that. So what else can you see? So if you're in the path of totality, you're lucky, and I feel fortunate, and I really hope the weather holds out for us, because that would be disappointing. Is that when you take, during that time, those 2 minutes or so, and make sure you have your watches set for when you put your glasses back on, you will be able to experience things in nature that are known to happen during total solar eclipses. So one is that the leaves act as little pinhole cameras, and you actually see crescents through the leaves that are basically projection of the eclipse itself. It's similar to if you take a piece of paper, you can make your own pinhole camera and just poke a little hole. Don't look at the sun, but have the sun go through the hole, and you'll see projected on the ground or another piece of paper the eclipse happening on that paper. It's like it's a projection, but the leaves do that in nature, and this is showing, I show on the little image there, a person doing it as well. So that's something you can try, and you can have all these little things set up if you don't want to always look through the glasses, or if you want to, this would be during partial, you'd be able to see that. Just before the eclipse happens, certain optical phenomena occur, and this just has to do with the sun, the moon just almost covering the sun, and one is called a diamond ring, and this is where the last sliver of the sun breaks into a ring around the moon, and it looks like a diamond ring, and it's called that for that reason. You do need solar glasses, so I put that little warning up there, solar glasses, so no one comes back to me and says, I looked at the diamond ring, and now I can't see anything. So just, I did what you said, and look at me now. So read that. Need solar glasses. But just before, right after the diamond ring, you'll see something called Bailys Beads. That's the nickname for it. And what it is the sunlight peeking through the mountains, valleys, and craters on the moon. And so it's really cool because it's the topography of the moon. And what you can see also in that image is a solar projection. And so one thing that's absolutely studied during total solar eclipses now, and I'll get to this a little bit in later slides, is the effects of the sun on the Earth, and that happens to be the outer layer of the sun, which you see that pink stuff coming out, and that's a solar projection, which is where we get solar storms from, and we're interested in that, and solar eclipses are a prime opportunity for scientists to study those ejections. Something else has anyone seen, I should have asked, has anyone ever seen a total solar eclipse?
I'm getting a video of this.
Oh, so I have signs. I was like, who's talking? It's the video.
It's going to be any second now.
Who's video? Are you videoing this? That's great. But this is something called shadow bands, and what you see are little wiggles on a car, and or it doesn't have to be a car, but it can be a piece of paper too. These are not well understood. These are wiggles that they could be from the atmosphere. It happens just before or just after a total eclipse, and you'll see possibly these wiggles on the ground, and they park their white car purposefully to see these bands. So that's something else you can look for. When you will also see, this would be cool, planets and some stars, and this is an image, an illustration of what should be visible during this eclipse, is you'll see Mercury, and actually the temperature of Mercury can be measured during an eclipse like this. It usually can't be when it's up, when the sun is out, because the sun is most of the temperature, right? It's much hotter, so you wouldn't be able to measure the temperature of Mercury. But you can see that we have Jupiter, Mars, Mercury, and then we have Regulus, which is a bright star. And so that could be a star where they might study gravitational lensing, Einstein's theory. So all of this is really cool. So twilight happens. So if you have seen other types of eclipses, just real quick, I'll say there's another type called an annular eclipse. This is the type of eclipse where the moon, because the distance of the moon isn't always the same, right? The orbit is not a circle, it's an ellipse. And so it means that the moon is sometimes farther away from us and sometimes closer. When the moon is at a certain distance where it can't cover the entire disk of the sun, depending on where we are, then you get what's called an annular eclipse for obvious reasons, is you have this ring around the moon. That is comparative to a total there, but you can't use, you have to use, again, those solar glasses. So another interesting effect from eclipses is animals and plants. And there's a citizen science project, and I'll put up this this website, but it's just a quick video clip of chickens sped up to show them going to roost during an eclipse. This is in Europe somewhere, and during the eclipse, the chickens go up, and they think it's twilight, and animals and plants will respond to this. And in the Citizen Science Project, you can record what will happen, what's happening around you. Are squirrels scurrying? Are birds not chirping? Are your chickens roosting? Is something else happening? It's been recorded that I read a really interesting story of someone out in Peru where the llamas just sort of stood in a line and watched. And I can just imagine what a donkey might do. They're very smart, and we have those. So maybe they take notes. I mean, who knows? But they stand there and they watch and they sense it. And the jungle sounds, and people in the zoos do experiments, or they do observations of animals to see. And that rooster is crowing right now. So it's morning again. They're not the smartest of animals. I can tell you for an absolute fact that that's true. Solar eclipses from space. So we have these great observatories, these satellite observatories. This is from the Solar Dynamics Observatory, and this is an eclipse of the sun seen from space. And after the eclipse, you're gonna, if you Google it, you'll find probably 10,000 images from space and from Earth. And this observatory is interested in looking at the effects of the sun on the Earth, and how the sun, living with a star, how the sun affects habitability of planets. And so eclipses are a great way to study that. And so we can understand a lot more about our sun by looking at eclipses. And so this is just a nice image from SDO, from this observatory. All those projections coming out, because the sun is so bright, they actually are hard to study without blocking out part of the sun. And so this is done sometimes artificially, but never as good as when the moon does it here. And so what you want is to study the solar corona. There's an actual image, and all of those projections are more easily studied when the sun is blocked out. Artificial eclipses are done. This is from SOHO. This is another satellite. That disk is an artificial eclipse, but it's not quite as good as nature's eclipse, actually, for science. And but there are scientists studying the solar corona using SOHO. All right, so partial solar eclipses, we can see those from space. This is another example. You can see wiggles in sometimes of in the atmosphere of Earth crossing, and magnetic particles coming off of the surface are studied regularly from these satellites, and all this other interesting science can happen when the sun is eclipsed, and only those projections are out. And so there'll be a lot of studies in those 2.5 minutes. I can guarantee that there's a lot that's going to be studied. So why do we care again? You may say, well, why does that matter? Well, all this stuff can get affected. So you have we have electric grids across the Earth. We have GPS that's affected. We know that there are astronauts up in the International Space Station, telecommunications, and these can't be predicted so easily. We know that the sun goes through solar minima and maxima, but we do get solar storms, and understanding how the sun works is still very much an active field of science. And so the eclipse will help with that. This is just one example, the geomagnetic storm and superstorm. So that square, all I wanted to show you is that square with the arrow is all that stuff happening. That's a storm. That happened, that affected radio signals, the electrical grid, and all that stuff. So we will be able to study that during this eclipse to see how does the radio signal dampen during the eclipse, and that's actually an interesting experiment to do. This is just a schematic to scale. This is we have essentially a force field around our planet Earth. You may not know that, and that's the magnetic field. It protects us from a lot of what comes out of the sun, but not everything. And so we do have to pay attention to the sun, understand it better. And again, this eclipse helps with that. This is just a quick look if you want to know where we are in terms of solar activity. We're in 2017, so it's not so bad right now. But again, it's just predictions, and we don't know for sure exactly how the sun's going to behave. So this is just a major eruption coming off in 2015. Luckily, we've been spared a lot, but during this eclipse, as I said, we can see effects on radio signals, measure temperatures of planets, and all that other stuff. Okay, so useful tools. I will end in a second. These are just some useful tools if anyone wants to see. These are ones I picked that I thought were cool. I really like this little video down at the did it get cut off? It did. I will fix that. But there's a video from Vox, which is a little 5-minute video, which had some I thought was a nice overview of some things with some interesting facts. And so if you want to know about that, I can I can move that up, or you can ask me after. So I will end there. I think that leaves plenty of time for questions, and I will just leave this up so you can see what you might look forward to. So thank you very much.
Let's give her a round of applause. Thank you very much. Fantastic stuff. I'm even more excited for it now. I can't wait. It's Q&A time. If you have questions, we're going to want to see your hands. I have a microphone. I'll be moving around the floor to try to get to as many of you as I can. And also, Katie has a microphone there, so look for one of us. If we don't get to you, just every now and then try to flag us down so we know, and we'll be going back and forth with the Q&A time. And then for this Science Cafe, given the topic, and I'm very excited for the crowd size, we also brought out, or had come out, I should say, some very special guests. Once we get to the end of our question and answer session with Rachel, we actually have the Living Poets are here with us tonight. They are alive. Living poetry.
I thought they were taking notes.
They've been taking notes. Notes. They've been writing poems as this has been going on, and we'll probably continue to write, I think, as the Q&A goes on.
All right.
Oh, I shouldn't tell you that.
Cool.
If you have questions, show of hands. We'll get to you with our microphones.
Okay, my question is, how does the path of eclipse affected? Like, what causes it to be here in North America rather than somewhere else, like South America?
Oh, that's a good question. Okay, so what affects the path? Well, the moon, we have this orbit in our solar system, right? And it has to be where the moon has to be on the same plane as the sun for this to happen. And so that is not the same every place on Earth, because the Earth rotates and the Earth is on an axis. And so it just happens to be the alignment of wherever the moon is in that point of time, every 18 months or so, where it is in the same plane as the sun, and it's just wherever the Earth is. So they can predict these out, as you can see in these online tools of where it'll be, but it's all has to do with the physics of the orbits of the Earth and the sun, and the sun doesn't really orbit, but it rotates on its own axis, and the moon itself. So it's just how it aligns over time.
Rachel, we're talking so much about eye protection.
Where am I looking? Oh, hello. I was like, what a ventriloquist over there. All right. Good job. Who's talking?
Hi, we're going to get the partial eclipse here in Raleigh. Will we see any of the effects like solar flares or Bailys Beads here?
Right. Well, you wouldn't see solar flares really don't have anything to do with the eclipse. It just that happens periodically anytime. That could happen regardless of an eclipse. It wouldn't be due to that. But you won't see. You really have to be in totality to see the effects around you, like the nature effects in nature. Bailys Beads and the diamond ring happen just before totality. So it has to be that little bit of sun, because if it's too much sun, then it overshadows everything else. The sun is so bright. And actually, it's funny, a friend of mine who lives out in Charlotte was saying, well, her kids want to go to totality, but does it really matter? We're at 99%. What's the difference? And I said, smart kids, first of all, because it really does matter. That 1% difference is completely different, because the sun is so bright. So even if you're in that 99%, and Raleigh's less than that as far as I know, is going to just be, you will see a disk over the sun, but you won't see the other stuff. So that makes a difference. If any of you have time to change your at-home plans, if possible, as far as I know, now I haven't personally experienced this, but from everything I've read and seen and heard, there isn't one bit of information that says it doesn't matter if you're not in totality. It's always that one point of go to totality if you can. So that's what my report on that. So yes, hello.
Okay, Rachel, now you're going to get 99 questions. The top one is, since we're talking about protection for the eyes so much, what about any protection for the skin? Is there anything we should be aware of?
No, well, you should always, I guess, wear sunscreen anyway, right? Here I am, giving you all these great tips. But no, it won't, essentially you'd need less during totality, because the sun, for those 2 minutes, you could wipe off and put it back on. But, it's just your eyes, because people want to look at it, and then you can really damage your eyes even if a little bit of the light comes through. But your skin is just, if you're out in the sun, wear sunscreen, right? SPF, whatever they say, but sometimes the temperature changes actually. So I don't know in the summer here in North Carolina if you're really going to experience a difference, but there have been reports of it dipping 28 degrees in some places during that moment, those few minutes of totality, which is pretty significant. So yeah.
I have a question.
Yeah.
is there a place on Earth where solar eclipses are more common or not as common as other places on Earth? Because you said the Earth is on a tilt and always rotating, so I don't know if that affects the way the solar eclipses happen.
Right, that's a good question. Is there a place on Earth? Not that I know of. I think it's just pretty like any one place on Earth. From what I understand, there isn't one place to go that's more likely to get, that you know you'll get a better eclipse, except the ocean, because chances are if you're in the ocean, in some part of the ocean, I mean, if you can sail quickly to the other part, it's just that, you know, it's roughly every 350 years for one location, and it's pretty random. It's random. It just depends on, because every place on Earth gets sun and dark. There isn't, we're not a planet where only one side gets sunlight and one side, like if you're on the moon, this wouldn't be the case where you'd only, every part on Earth gets sun and gets daylight and darkness at some point in the year, right? Yeah, go ahead.
Sorry, guys. So if Jupiter has more moons than the Earth, does that mean it has more solar eclipses that happen more frequently?
Yeah, that's a good question about the planets. There are solar eclipses. I actually took that slide up, but there are solar eclipses on other planets. It just depends on the size. Well, first of all, you wouldn't be able to stand on Jupiter because it's a gas giant. You'd fall down. So that wouldn't be good. But if you were on Mars, there would be, but the moons of Mars are not big enough to totally block the sun. So you have to, so there are certain, there's Pluto could have a solar eclipse. Mars could have solar eclipses. As far as how much totality, I don't have the numbers for you, but there are other planets with other moons. It just is the geometry. So there are a handful of planets where you would see that. Jupiter, yes, in principle, you would see a total solar eclipse, but not in reality, because you'd be in a spaceship hovering there, probably, your future self. So, yeah. Yeah.
I've seen warnings go by not to use counterfeit solar glasses, and I have yet in one of those articles to read how to tell the counterfeit from the genuine.
Yeah, that's a good, I don't know. So mine, I don't have a great answer for you, someone else here, but I've picked mine up at science conferences, so I figured they were fine. I've heard that there are counterfeit glasses. I would say if it were me to try to figure this out, I would go to a NASA site and then see where it takes you as far as finding glasses, and make sure you start with a reputable site, and they'll take you to a good site. And that's the best way to do it, is to start somewhere where you know that the information is going to be good, and not go to like Craigslist or something. Like that's my honest, is that because I don't know I don't know how to find out exactly, except that would be the best way to do it at this point. AAAS, yeah. Yep. Yep. Right. That's a good point. So the sites I put up, so 2017.org, Eclipse2017.org will take you to sites with glasses, and there are warnings on there too. AAAS, so AAAS, and NASA, those sites, if you just start navigating from there, you should be okay. Yeah? Yeah?
Has anyone done studies on animals that end up looking directly at the eclipse and what happens to their eyes?
You know, that's a great question, because I was thinking about that with the llamas. Like, do they know? And I have not, I don't think an animal would be dumb enough to do that, to be perfectly honest. Like, I was thinking about that yesterday. It's so funny you asked that, because the llamas were standing in the line. The guy said, well, the llamas looked at the eclipse, but I was thinking, did they really look at the eclipse? Because they should, and I think it's intuitively they don't look at the sun, because they wouldn't exist very well in nature if they were all blind llamas or whatever they are. So I think that the animals know intuitively not to look at the sun, so they just experience it as twilight. But that's a great question, because I was thinking, well, those llamas, why are they doing that? But they know. So humans, not so much.
Rachel, we have glasses information. I'm over here.
Good. All right.
From our wonderful scientists up in the astronomy lab, we got an email about this. So the eclipse glasses that you want need to be aluminized mylar or welder's glasses rated 14 or higher. So
good.
That's what you need to look for to not be counterfeited.
All right. So if you get to that
blinded.
point on your ingredients list for your glasses. Good. Thanks. Questions back there or wherever you want. Yeah.
What's the best way to video this with our cell phone? Is there a way?
No. Well, Okay, so if you don't have a filter, is that what you're asking? You don't have a special filter for your anything? There's
Correct.
Right.
Is there a way at all?
So if you feel confident that you know when totality happens, you mean totality, you can only film, the only way you can film it in Raleigh is if you're filming the projection with your phone, because you can't point your phone at the eclipse. You don't want to look through your phone at the eclipse because it doesn't have a solar filter. So what you need to do is put either project it onto in a pinhole way, and you through the leaves if you have leaves, or you use the paper method and then film it on the pinhole. I don't want to tell you that putting a filter over your iPhone lens would work. I'm curious now, thinking about it. Would that work? I don't know. So I don't know. But you could look it up, I guess. Can you put solar glasses on your iPhone? I mean, it's just that the sun getting in. I mean, any of the light getting through will damage your lens. So yeah, I mean, either the projection, just treat it like your eyes. That's the iPhone is essentially your eyeballs unfiltered. That's really what it is.
You showed us a picture of the chickens coming home to roost. What do we know about human behavior during a...
They go insane. Obviously, no. Right?
All these people here on a Thursday
Human
night.
behavior, gosh, what a prediction. I mean, I'm more comfortable predicting animal behavior. I mean, look, they travel everywhere. They come to science cafes. They buy out all the glasses on Earth. I mean, yeah, it's as far as so I don't think we biologically, like, anything happens that you can't control, if that's what you mean. I just think that you find it awesome. And what I hear on videos, when I play videos, I've watched like a million of these videos to find ones that I like. You hear, oh my God, wow, wow, wow. And they're screaming and they're clapping and they're acting insane. So, you know, it's supposed to be amazing. So whatever that comes out as. Yeah. Yeah, we'll have another cafe after the eclipse.
When were scientists and astronomers first able to forecast eclipse?
Oh, yeah, great question. Well, actually, to be honest with you, I think it goes back to, from what I read, it goes back to ancient times where they think that ancient astronomers, and by those I would mean like Chinese astronomers, Mayans, back centuries and centuries, they think they knew about the eclipses based on their writings. And so that is something that it could be true. As far as the exact noting of the dates, I don't have the exact date, but I would guess rough 1500s. I'm going to just guess here, so don't yell at me if I'm wrong. But I would think it goes back several hundred years, which is pretty cool if you think about it, because they had nothing really compared to what we have today. Good brains they had. Yeah.
Hey there. So I'm curious, and probably there's a really straightforward, simple thing that I just haven't thought of, but why is there a difference in the length of the totality period as you travel to different places? Some places it's a minute and a half, some places it's close to 2.5. Why?
Oh, you mean, okay, so along the band, it depends on where, it has to do with the Earth, with the moon crossing a curved surface, because the surface is not flat. And so it's just how much of the moon covers that surface. So you have this sequence, so you basically have a band, a 70-mile band. And if you're in the center, you get the most time. That just has to do with the geometry of the moon over, the shadow of the moon over the sun on a curved surface. So you can project that band. So there's a central band, that blue band, and so there's a handful of cities in North Carolina, which will be on the, but if you go past that, it just, the moon is a sphere, and the Earth is a sphere, and so that works out to be less minutes as you pass over the band. Then, if you're out of totality, then it goes back to your 70%, 60%, that sort of thing. But it just has to do with these are not flat surfaces, and so that's the spherical part of it.
That makes sense. Thanks.
Yeah. Yeah.
I wanted to be clear. Why exactly is it more dangerous to look at the sun during an eclipse than not, or is it just because you can't look at the sun when there's an eclipse, or when there is not an eclipse?
Well,
why is it so dangerous to stare at the sun before totality?
Well, so good question. So you're not supposed to look at the sun ever, right? You're not supposed to ever stare at this. Now, some of us, I know that sometimes we do. It's not good for your eyes. During an eclipse, people feel confident that the sun isn't bright because they look at it, most of the sun is covering it, and they're like, oh, this is so pretty, and they'll look at it. But there's a lot of damaging rays, but you're not as repulsed by it because you physically can take it, but what's happening in your eyes is damage, just as much as if you looked at the bright sun. But you don't perceive it that way because the sun is mostly is covered mostly by the moon. And so that's when it's most dangerous because it's not hitting you at full force, and people feel good about that, but really they're blinding themselves. And it's because it's a huge amount of UV coming at you. Yeah.
Hi, Rachel.
Hi.
I have seen solar eclipse before, total, couple of times. And so one thing I was wondering that, do you think it's rarer in the temperate region than in the tropics, the total eclipse?
No, someone asked me that a little bit about are there is it rarer or less rare? My understanding is it's not rarer in one part of Earth than another, with the exception of most of the Earth being covered with ocean. I might be wrong about that. I haven't seen anything, or my understanding of all of the physics of it is it's not. I mean, you may know better than I do.
I'm not sure because we were just talking about it other day, thinking that in India we have seen it quite a few times. Why don't we see total eclipse?
In the same spot though, or just in the large?
In the country, in the.
Which is a.
Well,
big
I remember 1980 in February 16th, 1980 or February 8th. There was one eclipse, total solar eclipse in Calcutta, and then I remember one was in 96. I think sometime in October 96, there was another total eclipse that in the same city, same town.
Right.
So.
Right. So that is right. So in Calcutta, you're saying. So yeah, I mean that could be the fortunate place. I mean, it just by chance that you had it. I don't know anything that should say that region of the Earth should get more solar eclipses than another, with the exception of if it's a big continent, you're going to get more of a chance, but that's not what you're really saying. And so I don't think, look, we have, in North America, we have another one in 7 years, which is great, but then the next one in 2045, and then not another one until another century. And so it's really, the average out is about once every 350 years. And so so I don't have a really good answer for you.
Okay.
So.
The other quick note is that if you guys are interested, there was a citizen science study done in India in 2010 where they looked at animal behavior, and some of the information that in the eclipsewatch.in website suggests that some animals behave, they behave like as if they are going back to roosting sites, and some don't. So it varies between in species.
Oh, sure. No, definitely. I wouldn't say that every species is going to react at all. And in fact, I left out a lot. I had a slide up with showing a spider web because apparently orb weavers take down their webs. Like they're like, all right, that's it. Nights fall for whatever reason, whatever's going on in the little head, and then they start taking it down, and then they start rebuilding it again. But it's select animals that I've read. I mean, I'm sure that the studies, I would believe you completely that it depends on the animals. Chickens are very day-night oriented. It would certainly depend on the creature. If you have a nocturnal animal, it may start coming out or not. I mean, you're right. I mean, it's complicated, I'm sure. And there also there's been studies of dolphins and whales behaving differently, which is really interesting. Like, they don't really explain it. They say they came to the surface and just sort of watched, it seemed, but who knows what they're really doing. The llama one was particularly fascinating to me. So yeah, that's a good point. Hey.
Hi. I have read that there are glasses out there which have the ISO certification on it that are not really useful. In fact, you can damage your eyes looking through them. I have also read that if you sacrifice a pair of glasses, tape the Mylar film over your camera lens, you can take pictures.
Okay. Great. So whoever asked me that, you're sitting right there. So you cut your glasses, tape the film on top of the lens, and according to the gentleman over there, and what's that? What he's read? Well, definitely contact him and hold him accountable. I'm just kidding. Just kidding. But yeah, I mean, I would, if it were me, I would make sure to do a lot of research on that if you want to keep your phone. But I'd be very careful with your eyes. And so if you, the glasses, as I said, like, and other people have mentioned, all those glasses would start with a reputable site. It'll take you to a good website. Yeah.
We're going to do
sorry,
one.
I'm sorry. Yeah.
We've got time for one more question.
Oh.
So the solar telescope that you're taking up there, you're going to be transmitting the signal here to the museum?
That's, yes.
Will it be available even after then? Will you make a recording of it?
Chris, we will be recording it. I think.
Absolutely.
Absolutely. 100%.
It'll be available if you wanted to. You could pull up the museum's broadcast live online. Livestream.com/natural sciences, I believe, is where it'll be, and maybe a couple other places. But keep a lookout on the museum's Facebook page. Follow us if you're not already. Right? That's a good thing to do.
Great.
And that'll be archived. You'll be able to go back and watch it every day for as long as you like.
I think we have one more. Can we get one more? He really had his hand up for a long time.
Well, so we have to move on because
oh, right, the poets.
I want to hear this fabulous artwork
I really
that's come
do too.
through.
Hopefully they're not sad. Oh, good. Okay. I feel so sad after this talk. I hope not.
So just so everybody knows, every now and then for some of our science cafes, we have a group of poets. They come out, and during the cafe, while our speaker is presenting, they are writing poetry. So everything you're going to hear from these wonderful people has come out of their brains within the last hour. So make sure introduce yourselves and... Oh, okay, she's going to... Thank you very much.
Yeah, thank you. This has been a great time. Thanks, Rachel, for the talk. I'm Angie Kirby. We're all from Living Poetry, which is a meetup group in the Triangle. We get together, write, talk about writing, read, talk about writing, and write. So I want to give you my Eclipse poem written while Rachel was talking. Can't see all of it. How to survive an eclipse. This is why no one tells us about the loss to come. We'd stand in line, sit in traffic, buy front row seats, best view of the demise, even our sons. Its ring left on the table between us. Don't look directly at the loss. If seen with the naked eye, you'd remember green, grass, gone to splintered gray. Roost with hens, let day give up its ghost to you. Bay at the moon. Let umbra be your umbrella. Come sit with us apes. Dumb, mouths full of stolen bright. Llamas say it's butter. Light that tastes like night.
Thanks. I'm Tara Lynn Groth, and thanks for Angie for facilitating this here for us. If you're interested in more about Living Poetry, you can check out livingpoetry.net for all of the events. This is Untitled so far. Every poet places a moon in a poem, like slipping a ring on a finger. It's a promise to the reader that the verse will be deep and honest. Then the moon moves and makes its own diamond ring. Starlight bends, and the poet is torn, counting Bailys beads in a prayer, asking for an answer. What good is a moon in a poem without bent starlight? In those moments of darkness, wait for the answer to illuminate, for the chickens to come off their roost in thuds on the coop floor, for the silence to break and the day to fill with the promise of its light.
My name is Bartholomew Barker. When someone says, beautiful day, I cringe. I hate the sun. Harsh, burning, yellow, bright. I wear eclipse glasses all year round. Call me Endymion. I love the moon, her gentle light bathing the night. I would give her my diamond ring and a necklace of Bailys beads if only she would hold the sun in eclipse forever.
All right, my name is Anna Weaver, and I am batting cleanup for poets. In my head, astronomers only exist at night, always drinking coffee and squinting into small eyepieces and goofy glasses, muttering to the moon over the squishy soundtrack of Space Invaders. Next week, they will turn diurnal, and the highways will be lousy with them, mad for the Super Bowl of space, minus the hot dogs and commercials. Numbered jerseys replaced by star-patterned tank tops and moon phase ties. All morning, they will drive to converge on a diagonal, to stand in a thin ribbon of nothing but shade, to graft the crown jewels of corona, diamond ring, glittering beads, to eavesdrop on the private yoga of light bending as the sun slowly backs away, hinting a billion years early at the true meaning of totality. Thank you very much to the museum for having us out. If you are all now really super into poetry, I encourage you to go to sparkcon.com. There is a festival downtown in September, and there will be a lot of poets and literature geeks out there doing the poetry thing. Thank you.
You guys are amazing. Yes. Oh,
Well, who's excited for the solar eclipse? Yeah. I think so. Fantastic. Thanks to y'all for coming out tonight. Thanks to all of you for coming out to the Science Cafe this Thursday evening. I want to let you all know before you leave, there are survey forms on the tables. Fill those out. That lets me know how great of a job I'm doing. Thank you. No, don't clap for that. But that does make sure that we're giving you what you want out of evening programs here at the museum. And if you enjoy this kind of thing, it's made possible by you. Right, the North Carolina Museum of Natural Sciences is a state museum. It's free to come in the door. Almost all of the programming and events that we do here at the museum are free. And that's not just because of the legislature. It's because we have great people like you who join our Friends of the Museum, become members of the museum, and actually support what goes on here. So if you are a member, thank you very much. If you're not, you will be soon, because this kind of stuff is fun, and I think you'll appreciate it. So stay safe on August 21st. Make sure you've got good eclipse glasses, and I wish you all the best solar eclipse viewing on August 21st. Next Thursday night, we have, let me remind everybody, next Thursday night for the Science Cafe, we are doing weather forecasting and the military. You can imagine those two things are very important to one another. So I hope that we'll see you all here again at the Science Cafe. Bye, everybody.
So cool you guys could do that.